grade sevens. Patrick's in the back of the room. Give him a wave, Patrick. Thank you very much. Time for your flip video. By the way, what I want you to do, when I tell you to pause, and I mentioned this in class, when I tell you to pause, I want you to pause the video, go get a parent, your mom, your dad, or anyone else who happens to be in charge. Go get them, bring them to the computer, then restart the computer, and I'll tell you when to pause again. Okay, so let's go over that one more time. I'm going to ask you to pause the video, go get someone, bring them to the computer, let them see what we're talking about, and then I'll tell you when to pause and you can move again. Okay, so when I say pause, pause and go get somebody. 3, 2, 1, pause. Okay. All right, we're back. Mom, Dad, whoever happens to be in front of the screen, tomorrow night, Thursday the 26th, is our open house here at SJAM, and we want to invite you to come on down and join us, say hello, reacquaint each other to what we're doing. We want you to see our brand new classroom. We want you to come on up and see what we're doing, and more importantly, I have some really great online resources that we're incorporating into the class that you may or may not be very well accustomed to, or for that matter, acquainted with. So come on down. We're going to meet for the first half hour in the gym. Pizza will be sold. There's going to be a barbecue on the go. And then after that, we're all going to come up to the classroom and I'll show you what we have going on. So that's tomorrow night. It goes from 6 till 7 here at SJAM. Okay, so 6 to 7 tomorrow night. Make sure you come along. And since I've finished with that, I'll bring the kids back. All right. Now, for the kids, what we're going to be talking about is comparing ratios. Okay. So far, you've worked with ratios, you've worked with rates, but one of the things that you need to start thinking about is how you can compare what a ratio means. If I said what was bigger, a ratio of 3 to 5 or a ratio of 5 to 7, it might be difficult for you to nail down exactly how to explain what is bigger than the other. This is the last thing we have to do with ratios before we move on to things like geometry, okay? And it applies there too, okay? So what I want to do in this lesson is go through how to compare ratios to determine which is bigger, which is the same, which happens to be smaller, whatever the case may be, and go through some assignments that you can to help you practice that, all right? So here we go. Okay, so what we're looking at now is how does the ratio affect size, okay? And I'll give you a perfect example, okay? Every single morning when Mrs. McClung and I make coffee, it's either Mrs. McClung or myself who make the coffee, and we try to take turns. But for some reason, the coffee tastes stronger when one of us makes it than when the coffee is made by the other person. The more coffee you use to water, the stronger the coffee is going to be. So if we can look at the two ratios that we use and the way we do it, maybe we can figure it out. So what we figured out is Mrs. McClung uses a different ratio that I do. She uses 2 scoops of coffee for 5 cups of water. I use 3 scoops of coffee for 7 cups of water. Now, it's not immediately clear there exactly who uses more. But if we work it out a little bit, we can. Let's break that down a little bit. If we look at Mrs. McClung's coffee, 2 scoops of coffee to 5 cups of water is a ratio of 1 to 2.5. If we look at the way I make the coffee, it's the ratio of 1 to 2 1/3. Since there's more coffee to water in Mrs. McClung's ratio than there is in mine, her coffee is going to be stronger than my coffee. Okay? So the idea is, can you break this down to actually prove who has more? Okay? Let me give you another example. Let's take a ratio of boys to girls, okay? Give you a situation. You're going to an outdoor center, okay? There are the same number of boys and girls. 5 out of every 8 boys want to kayak. 2 out of every 3 girls wanted to kayak. So on the boys' side, it's 5 out of 8, okay? I'm just going to wait this to come on up. 5 out of every 8 boys want to kayak. On the girls, 2 out of every 3 girls. Whoop, let's change that number again. 2 out of every 3 girls want to kayak. So, what's bigger? Well, you can figure it out in a couple of ways, okay? The ratio here, of course, 5 to 8. The ratio here, 2 to 3. To compare them, what we have to do is find a way to get the numbers as close as possible. Okay, and you have to think of common multiples. So just like as if you were trying to see which of the two, if we turn these into, say, fractions, you want to see which fraction is bigger. Is there a common multiple between, say, 8 and 3? Now, if you can't think of one, the other thing you can do is you can use 3 as a multiple of 8, or 8, and then 8 is a multiple of 3. Here's what I'm talking about, okay? If we were to do this, if we multiplied 3 times 8, we'd have to do 5 times 3 too. So 5 times 3 and 8 times 3. And on this side, 2 times 8 and 3 and 3 times 8. You're going to get equivalent ratios. Watch what happens. 5 times 3 is 15. 8 times 3 is 24. On this side, 2 times 8 is 16. 3 times 8 is 24. What is the largest ratio? There you go. So in the questions you're going to be asked over the next little while, put this strategy into place and see if you can figure it out. Okay? Either go back to that strategy we were looking at when you turn them to a ratio and then to a set of fractions, or try to figure it out by equalizing the fractions and find out which one of the two ratios is the highest. Okay? Your work is included on the page. Go to it. Let's see how well you do. Good luck. We'll see you tomorrow morning.